Hey guys, so this is the series that I was given for my problem. As we can see, it's an alternating series as the values go from positive to negative to positive to negative. So for this, I'm going to be satisfying the conditions that the alternating series test needs to prove its convergence. So the series that is the equation that creates this alternating series is as n equals 1 goes towards infinity, negative 1 to the power n plus 1. The denominator is 2n minus 1. And we can plug in these values from 1 and 2 and so on to get the series that we have. So the two conditions that we have to satisfy for the alternating series test is to show that b sub n is equal to 0 as n approaches infinity, and show that b sub n is decreasing throughout the series. So first we'll show that b sub n equals 0. So we'll see that the series a sub n, negative 1 to the power n plus 1 over 2n minus 1 is the same as negative 1 to the power n plus 1 times 1 over 2n minus 1. So we'll generate our simple equation for b sub n, which will just be the 1 over 2n minus 1, which is what we'll use to satisfy the conditions. So when we have b sub n 1 over 2n minus 1, we can divide the top and bottom by n, and then plug in infinity, and that'll give us 0. Thus, the first condition is satisfied for the alternating series test. Let's see here. Next, we will show that b sub n is decreasing throughout the series. As n is approaching infinity, we'll see that the denominator is increasing in value, which will ultimately make the value of the fraction getting smaller and smaller. So we will compare b sub n plus 1 to b sub n. So by plugging in the n plus 1 on the left side, we will eventually get 1 over 2n plus 1, which is less than our original b sub n, which is 1 over 2n minus 1. Move this up. So here we can see that the denominator increases in value, which ultimately reduces the value of the fraction as we plug in our increasing n values. So yeah, this will show that as we increase throughout the series, the number will be decreasing as approaching infinity, which will get closer and closer to 0. So it is decreasing. And on the left, I also, as a second form of proof of satisfying this condition, I plugged in a few n values, n1, n2, n3, and n4, which we got 1, 1/3, 1/5, and this is 1/7, which these are the values of our original series. This is just all positive numbers for b sub n, but we can see that the fraction is getting a smaller and smaller value. So ultimately, for our series as n approaches infinity, negative 1 power n plus 1 over 2n minus 1, the series converges by the alternating series test.